Thank you. Hey everyone. Hola. Is that the correct? Hola. Cool. I always check I'm in a foreign country when I use words that I read off the internet. So I've got another one for later. So we'll see how that goes. So yeah, welcome to my talk where I'm going to be sharing with you some research that I've been having with Android malware. So who am I? My name is Chris. I'm a security researcher / engineer. I don't really like labels, but that's kind of the stuff that I do. And I do this full time at a company called Heroku. And yeah, you can find me on Twitter, Rompony. It's probably the easiest way to find me. So yeah, enough about me. This slide just helps me just to remember what it is that I am discussing today. So there was a problem that I experienced, one of many, some time ago. There was an interesting question that I was asked that triggered an idea, which led to a POC and some results and a conclusion. And this slide's also in there because I was told when you do a presentation, you've got to have some sort of slide that's going to tell the audience what they're in for. So if this doesn't seem like something that's going to keep you entertained for the next hour, I'm not offended if you leave now. So what's the problem? And I'm pretty sure that most of you in this room are looking at this and being like, yeah, I know this. And it's a big problem that we still continue today. These are just some of the headlines from the past 2 years, but pretty much since the inception of Android, it's been synonymous with malware. Android malware, it's kind of like coffee and the dessert that we just had. What's the name of it? So it's like coffee. What he said. So it's a common thing, and I'm not going to go into too much about that. But I saw this problem, and I wondered to myself, well, how easy is it to create skiddy malware? So at the time, this was a couple of years ago, I was thinking, well, what's the easiest way to backdoor Android applications once off for a skiddy? Just run a app or script and boom, you've got a fully backdoored existing Android application. So this is a tool called Quetzal that I released a couple of years ago. This was before MSF Venom had APK backdooring capabilities. And I was sharing this tool with some researchers in a desert in Northern America. And most of the questions I got were mostly the usual InfoSec questions. Like, how do I bypass antivirus? How do I prevesc? How do I use additional payloads? And those are the usual questions that I was used to. But I got one question from an engineer that was there, and they said, Chris, how do I detect on my phone or my application if it's been backdoored or tampered with? And I thought, well, that's a great question. We would have to resort to our normal reversing techniques, especially with malware. So firstly, you're going to need the APK. So statically, you're going to tear apart that bag of bits and look at it. And of course, you're going to run it in some sort of sandbox. And these were the two main points of my answer to this engineer. And I actually really wasn't happy because I started then looking into the current techniques of how we look into malware. So at this time, I was not a malware reverser at all. I was just mostly interested in POCing techniques that I could prank my friends with Android phones. Pretty much being like, well, this is what can happen. So I dug around a bit more, and these techniques aren't limited to Android or mobile, but mostly malware reversing and good old hashes, code signatures. So pieces of code have popped up in APKs and samples around the world. You can identify it. Permissions is quite specific to Android. For example, if your grandmother comes up to you and says, I installed this app and it turns my phone into a torch. I am so excited. But it's really expensive when it sends those SMSs. So immediately I'm thinking, well, looking at the permissions, and you're thinking, well, why the hell does Torch app need your GPS, send those prime SMSs, access your contacts, and every other thing? So that's quite specific to Android. It's always a good place to look at the permissions to see what it's asking. And in generally, if it's for free, you are the product, which leads to reputation. When I'm on the Playstore and looking for malware samples, I always look at the free apps. That's just a dead giveaway. All the apps that claim to offer a service that is normally paid for. So the whole free VPN service or, free Viper or whatever. If it's free, it's got something, either mining Monero or something else dodgy in there. And then of course behavior. If you install that app and all of a sudden your battery is being depleted very quickly or your data usage is going up, those are the kind of indicators. So nothing really new here, but I was looking at these ways and I thought, well, okay, those are how we reverse malware, but how are we protected? So we have Google Play Protect. Anybody heard of or remember Google Bouncer? Your hand up? Okay. That makes sense. It died a slow and painful death, but it's now Google Play Protect, which is a team, and if you notice on Android, you'll get that notification. Do you want to have this application looked at? And yeah, there's an interesting story there on how they're scaling out. Then of course you have the Google Play Store. So, when you download an app from any of the Play Stores, it's been verified, so it's legit. So that's a defense mechanism. I'm being a little bit sarcastic now. FYI, I have a weird South African accent, so sometimes my sarcasm doesn't come through. So I just reiterated. So don't worry, if you're not understanding me, I don't understand myself either. So we're in the same boat together. And then of course we have third-party software, and I'm really going to crank up the sarcasm. We have antivirus. I'm so glad so many of you are giggling. Antivirus and mobile is an oxymoron. Well, just in general, okay, on desktop, antivirus is great because, how else are you going to get system? That's a great prevent mechanism, don't want to make it too easy. Anyway, I'm going to shut up about antivirus now. As you can see, I'm a big fan. Then, of course, there's operating system support, so, Copperhead. I'm not going to say CyanogenMod there or Oxygen OS, but there have been some operating systems that have implemented some mechanisms to protect against malware. So a nice example is actually seccomp capabilities that the Linux, or that the Android kernel released a while back to actually limit the syscalls that processors can access on the operating system. And this was actually due to malware and privilege escalation bugs on Android. And then of course you got your MDMs and your MAMs and all those things that don't really work too well. But if you're in a large corporate and you want to control what apps are being installed, you want to push a VPN profile, you want to enforce a password policy, those things can help thwart malware to some extent. So, what are the shortcomings? So what I realized, static analysis is hard. For me it is. In the Android space it gets really interesting because you can stare at Java or Kotlin if you want. Or you can go a level lower and stare at Smiley, that's alright. And if you really hate yourself, you can look at all the different ARM variants. You can look at, either x86 or MIPS if you're feeling really adventurous. But if you're just looking at ARM 7VA, or ARM 8, 64-bit, that stuff gets hard, to me at least. Because if I'm just looking at 32-bit ARM, that's alright, I can kind of navigate it. Give me 64-bit, no thank you. No, it's not going to happen. So static analysis, it's difficult, especially with malware. Then all those other points, which I'm sure all of you have read by now, all my animations are disabled due to hearing stories about the setup for sites. No, I'm not bashing the setup, just thought, let me decrease the amount of things that can go wrong, and animation generally is the first thing. So all those things on the board, you can't run Cuckoo on your phone, so you get a nice malware sample, you throw it on Cuckoo, give you some information. I can't do that on my phone. I'm here in Lisbon, and if I think an app's dodgy on my phone, I'm going to have to open up my laptop, get the sample off, which then scales down to scalability. So at Black Hat this year, Maddie Stone from Google Play Protect gave a really good talk on how she spent a considerable amount of time reversing a sample that had very awesome anti-instrumentation techniques, anti-tampering techniques. And this is a prime example of scalability. They couldn't detect the sample automagically. The sample had to be put in front of an analyst, and this analyst had to sit for a considerable amount of time, a couple of weeks, if not months, to actually understand this code and then add signatures to detect this. So for every piece of malware that comes out there, you're going to need hundreds, if not thousands of analysts, and that's just not a reality that we have today. So yeah, other shortcomings, what if the app's not on the official store? Who's never, side-loaded an application or, wanted to get hold of an app that wasn't in their Play Store? In South Africa, we had the problem when the best app ever, Pokemon Go, came out. We didn't have it in South Africa. So what did we do? We got it from third-party sites. And yeah, I trolled my friends big time, but that was for educational purposes. Of course, forensics is really cool for analyzing, but try to do forensics on a mobile phone, using a mobile phone to analyze a mobile phone. Different story, probably future research. And then, of course, bypassing AV is just too easy. I spent a lot of time with that with Quetzal. How many times can you just change the permutations just to bypass antivirus? Because, who's not heard of interpreter payloads? Who doesn't detect it? Well, if you just change a couple of strings, mobile AVs won't. That was some time ago, but it's still quite easy. And then, last point, and I'm sorry for all these points in one slide. I know I fall asleep when I see things like this, so I won't be offended if you do too. But static analysis only shows you a subset of functionality of what an application is going to do, especially when it comes to droppers, and I'll go on a bit about that. So these are some of the shortcomings that I saw, and I'm sure that there's more. So if you see more, please tell me. But the main thing that was irritating me and probably reliable for me losing a lot of hair, that's why I wear a hat. Not just to blend in with the local hipsters, but there was, or still is, really no reliable way to detect malware on a device using the device. You need to open up your hack top, you need to fire up ADB, you need to rip off the APK. It's just not a viable thing. And that irritated me a bit because A, I'm super lazy, so if it can't be scripted or automated, I'm like, well, whatever. So I wanted to do that. So then I had an idea, and these don't come along very often. And I thought, well, there's heaps of data. Bad joke number one. I always say, I'm sorry, I apologize for the bad jokes, but they're going to happen. So I thought, well, okay, there's the heap on Android. We'll leave the stack alone for now. And I thought, well, when I'm looking, import statements are useful, but what's even better is that Android apps make use of objects. You can import a class to create an object, but you may not necessarily instantiate it. But when it comes to objects, if it's been instantiated, it means that it's probably being used. Unless they're a really terrible dev, like me, if someone's typing out object X equals new object, they're probably going to use it. If they're not, well, maybe they should consider an alternate career path. But instantiated objects are a lot of fun because they have data. When something is sitting in an object, it's there for a reason. And when actions need to be performed, it's a great way to look at what it's doing. So, we want to look at objects for Android applications. So, they live somewhere special, they live on the heap. So, first thing you hear, heap, Linux. And if you hate yourself, you open up proc, PID, and you look at maps. Anybody familiar with this dark, deep region of the Android or Linux operating system? Yes. And you can look at the heap regions. Pretty useful, the mappings are pretty cool. But yeah, unless you know dlmalloc or jemalloc really well, then it's going to be difficult to deduce that information. So the next best thing is HP RAW files, right? I mean, attach a debugger process, you dump the HP RAW file, you make a cup of coffee, you have some dessert, you have a nap, you come back and you might have a HP RAW file dump, which then, you're going to run extreme amounts of greps over and hopefully you'll find something. Not so great. Next step, forensics, volatility and LAM. Really great, but not that feasible because it requires you to patch kernels. And of course, it takes snapshots of the entire device's memory, not just specific processes. So proc and the PID maps is for a specific process that's running. Forensic tools are mostly designed towards the entire device's memory contents, which then requires additional processing. Last but not least, my favorite, good old GDB. And I don't know why I came to this option last, but what I realized was, especially on Dalvik, is that if you just fire up a GDB process, and if you run hash code, so on any object in Java, you'll get a nice and weird-looking string that is actually the starting base address of an object. And if you go to that in GDB, you'll see your object, especially in Dalvik. ART, different story. Won't get into there, but this just differs due to the use of jemalloc and dlmalloc. And it's actually a really fun way to scan the heap and have a look at what is actually running there. So I thought, cool. Now I know where everything is running. If I can see what objects are on the heap, I can deduce what this app is doing. So, extending on this idea, I thought, well, yeah, GDB is fun, but do I really want to interact with GDB over some mechanism via an Android app? I mean, it sounds like I really hate myself at that point. So I thought, well, okay, objects are accessible, and of course we have instrumentation, good old ptrace. And then of course on this framework we have Frida. Anybody here Frida? Yeah, if you don't know Frida, I'm such a Frida fanboy, really play with it. It is amazing. One of my favorite instrumentation frameworks. So I thought, well, this is relatively easy. I want to do some object carving. And the object carving capability just blew my mind. It works really, really well on ART. The Dalvik support is somewhat lacking because, Dalvik's a dinosaur unless you're into archaeology. you might want to look at it. But I thought, great, let's see what we can do with Frida. And it turned out you can do it really, really easy in Frida if you say, given this process, tell me if it has object X instantiated. So I thought, okay, well, wouldn't it be cool if at runtime, I'm using my phone, not an Android phone, but yeah, in this case an Android phone, and I thought, well, which objects an app is using, if I could see all of this, which objects are instantiated, and what are the values for these objects? Because everything that you're typically doing in an Android app translates to an object. If you're making an HTTPS connection, there's going to be some HTTP object or a TCP object somewhere with some data inside of there. So I thought, cool, this is really awesome because this would give me an idea as to what an app is doing and how, which relates to reversing anyway. When you're reversing an app, you want to see what this app is doing. You want to understand it. You want to know why is it making connections to spaces, to IP spaces in Asia. You want to understand that. You want to know why. You want to scratch that itch. So I thought, well, for example, we're going to look at something, and everybody familiar with Meterpreter? Yeah, it's a nice platform to play with. It's a good start. So I thought, well, if I was analyzing, if my friend came up and said, hey Chris, I installed this app and it's acting a bit dodgy and I got it from, a friend who was talking about Metasploit a lot. I thought, okay, cool. So I'm probably going to be looking for a Meterpreter backdoor. And experience tells me to look for a couple of things, but most notably, DEX class loader or any class loader and what that injected code does, because that's how Meterpreter works. The stub is really small. All the cool functionality gets loaded on as jars at runtime after the infection. And then, of course, TCP objects, because Meterpreter communicates over TCP or HTTPS. There's no DNS X4 yet. Which tells me that if an APK, or if an application at runtime had an instance of a DEX class loader object and a whole bunch of TCP objects, this would tell me that the app is loading a functionality at runtime and establishing remote communications, which would send alarm bells, because why on earth does this app want to use a DEX class loader instance, which ironically happens to be a very common technique to update apps, because the Playstore doesn't say if you want to update your app, you need to go through the Playstore, but who reads the T and C's anyway? So, we're going to start with a infection. Now, I do apologize for the resolution. It is a bit weird. But in that case, we got an Android device, and what I've done is I've just backdoored the Twitter application for shits and gigs. Why not? You can do this to any app. And this is the infection that we're going to work with going forward. So we can see we run the Twitter app, and we get a Meterpreter session, and what we're then going to do is interact with the device that's been infected so that we actually have a process that's running and something that we can look at. And what we're going to do is we're going to take a screenshot of the user putting in their credentials. Now, of course, in this case with Meterpreter, you can do it because an app can screenshot itself, not other apps. This is because Meterpreter is running in the context of the Twitter application, or the backdoor Twitter application. So take a screenshot, and I was definitely much slower when I made this video. Definitely much. Probably had less caffeine as well. But we open it up, and woohoo! We have an infected device. So once we have that, how do we analyze this using Frida? So what I'm going to do now is, yes, it's written in JavaScript, I do apologize, but it is quite literally the easiest way to interact with the Frida daemon. These scripts and all that, all online, so don't worry, you're just going to have to believe me when I tell you what's happening here. Don't question anything. Sarcasm once again. But what I'm doing over here is I'm saying to Frida, I'm connecting to you from my workstation, and that JavaScript that you see over here, I'm going to say, look for these kinds of objects. So in this case, I'm looking for java.net.socket, dalvik.system.dex class loader, java.url connection, and I'm saying connect to the Twitter process. Now you see all this information here. These are all the instantiated objects that I've looked for. So we can see that there are a whole bunch of objects of java.net.socket that have been instantiated and that are currently living on the heap. I then go ahead and I query these objects, and I can see IP addresses. And host names that have been resolved. So I can see at this point in time, this Twitter application has a connection to 192.168.1.120 on port quad 4. I wonder what that is. Quad 4, I mean, who knows what runs on quad 4. But most interesting observation is at the bottom is that there are two instantiated objects of Dex class loader. And you may be wondering, why on earth would this application need two instantiated objects of Dex class loader? Well, like I said, because I'm looking for Meterpreter, I know that this is how Meterpreter loads its functionality. And you can do this for any objects. If you're looking for overlay attacks, there are specific object patterns that you can look for. So you say, here's process X, tell me if it is using these objects, what are the values of these objects. If they are there, you can then infer some information. So that's how we do it via Frida, and it's very interesting to just say, tell me if these objects exist, yes or no. It's the lazy man's way to analyze stuff. How does this look on other apps? So this is a dump of the YouTube app on Android, and as you can see when you run it, it has a whole bunch of java.net.socket objects that are instantiated, and then it has an instantiated instance of Dex class loader that is called, let me read it off the screen. It is called ADS. I don't know what ADS means, but A778244.jar. So that's what the YouTube app is doing. It's downloading a jar when you run it, and it's taking the contents of that jar and the functionality and invoking it at runtime, just as Meterpreter does. Pretty cool. I love legit functionality. So what's the difference between static and runtime analysis? So I mentioned earlier that static analysis is not going to show you some stuff. And what it won't show you is the runtime injection of class loaders. Why? Because when you load it at runtime, you need access of that additional jar or APK that is then loaded into memory. If you just have the initial APK, you're not going to see the other APKs or jars that are injected. So you're not going to see the information unless you run it in Cuckoo or in some environment where remotely you download the jar APK and then you reverse that as well. So you're not going to have that. Then there's also, probably my least favorite Java package is java.lang. Not because it's Java, but because every process gets an instance of this class and subclasses. And for those of you who may be familiar with Java payloads, there's a very interesting object and method called runtime.exec. So every single Java process has its own singleton of runtime. And if you want to run a shell command, you say .exec or you use process builder. Now, you don't need an import statement because every process is automatically given an instantiated instance of this. I say it's kind of immutable because it's very difficult to control the contents of those objects. So you kind of just hope that whatever process is using those objects, it kind of gives you data. But I'll go on a bit about that. So that's what you're not going to see with static analysis. So I'm now going to show you that. Well, I'm going to show you a video and then tell you why you should believe that. These videos are all online as well. You can see my very shitty code. But what I'm doing over here is to the left, yes. So there's a vanilla Android application, and what it is going to do, it is going to load at runtime an APK that is generated from this. So here is an application. I take this and I bundle it into a jar. At runtime, I then go ahead and load the contents of this jar at runtime over here, and that's the functionality. I then have my Frida script that is then going to say, look at this process and tell me what's in memory at runtime. So of course, there's the application, and I'm actually going to debug as well. So at the first point that we're going to do, we're going to run the script, and we're going to say, at this point, it's not picking up any of those dangerous objects that we were looking at earlier. It's picked up nothing, which actually makes sense. But then we run our breakpoint, we ran the run stuff method, and at this point, all it's done is it's just created a file, we run our script again, and we'll get nothing. Yes, okay, I got that right point. We then step over, and what we're now going to do, and even my screen resolution has gone really small. So what we're going to do next is create an instance of Dex class loader, yes. So we just stepped over that method. We instantiated an object of Dex class loader, we ran our script, and what did we get? We saw that an instance was on the heap, and we got the contents of it. We then step over a whole bunch of stuff, and we're now stepping through the functionality that we've now loaded into memory from this additional jar over here, which you won't see. So we just ran a println method, we ran our script again, and we're not picking up anything more. What we're going to do next is actually issue a HTTP request, a shell command, that's the next one. And we've just basically run an ls, and we can see the contents. So all we've done is run exec bin ls, and we can see the contents of it in logcat because that's what the code is doing. And what's going to be interesting now is that when we run our Frida script, we're actually not going to see anything interesting, because the runtime object is very difficult to inspect to see if someone has run a shell command. If you do know how to, please tell me. I have not found a way yet. Well, I found a hacky way to find it, but it's quite difficult. Next, we're then going to actually run an HTTP request over here, which is this functionality. So this app is going to run an HTTP request, which is defined in this jar over here. And my favorite way to see if an HTTP request has been made is that Android throws a lovely fit, because you're not supposed to run HTTP requests in the main thread of an Android app. I mean, who's going to tell me how to make my HTTP requests? But anyway, we see that request coming out, so we know it's been executed. And what we then go ahead is actually run our Frida script to actually see, okay, I've now run an HTTP request. What is the content of the object? Are there objects? And that should be the next one over there that we ran, and my video just abruptly ended. Hold on, let me find the right spot. There we go. Sorry, I just stopped at the end. So at the end over here, after we ran that HTTP request, we then scanned the heap and said, tell me if you see any java.net.url objects or any TCP socket objects. And we did, and we get the information over here. So static analysis won't show you that unless you have both the APKs, which in some cases you do, but in most cases you don't. So I'm a big fan of this method because A, I don't have to trawl code. I mean, like I said, as you probably picked up, I'm a big fan of static analysis. And it's very cool to identify specific anomalies. You don't have to just read lines of someone else's rubbish code. You can just say, look at this process and tell me if you see any of these specific objects. Easy peasy. But there's also some frustration, and I'm going back to java.lang.runtime. So if I wanted to see if a process was running shell commands on my system, I'd have to inspect the runtime object. But what you see over here, and if you got ninja eyes, you might make out that. I'm going to look at my screen though. This is what a runtime object looks at runtime. I just loaded it up in a debugger. And you'll see that it is full of information that makes no sense to me whatsoever. But there is no way to say, hey, this process just ran bin PS. There's no way to find it. There probably is, I haven't figured it out yet, but it's not obvious. So that's annoying. But of course we make a plan. So, what is fundamental to objects? Of course, the rest of the points say that, but methods. And what's really cool that we can do with instrumentation is that we can hook methods. Method swizzling, it's the greatest way to, if you're reversing that app and you want to get past cert pinning, yeah, you just bypass that check. So we can do the same with Frida. We can say, for this particular object, every time this method is called, tell me about it. And it's a classic way that we use to basically pwn mobile apps. But I thought, why don't I use this to hook the exec method for the runtime object, so that every time a process issues that method on that object, I will see what's happening. So I firstly have to apologize for showing you Java documentation at 5 o'clock on a Saturday. I do apologize, but it's crucial for this point. But if we look at the exec method signature, it has got 1, 2, 3, 4, 5, 6 different combinations, different signatures. So all that we have to do in Frida is cater for that. So we have one method signature that just takes a string, one method signature that takes all the other stuff. And we overload that. And of course there's a video that you'll see, if you have ninja eyes, But in this case, what we're going to do is we're going to use the same sample that we were using earlier, that shitty app that I wrote that just ran bin PS. And these are all the signatures that are going to catch. So I'm going to tell Free to hook onto the process. Now this is very intrusive. Here we are modifying basically functions here, but that's besides the point. So what that means is that every time the process that we've hooked onto has executed the exact method, we'll get some information. So we're going to run our app that ran the bin PS, and hopefully we will see something. And that is that method right over here. And remember, this functionality has been loaded at runtime. So we've taken a jar that executes the bin PS command and thrown it into memory. And we go ahead and we will run it at some point. I'm not running this in an emulator, by the way. I'm using Varsol, so just streaming off the device. Really, really handy. And we just ran a exec command, and you see a whole bunch of information. And what you'll see actually over here, this is saying exactly system bin PS. So now we can see that this process is executing shell commands. Now, this video was originally for developers only, so I made it very slow and repeated a lot. I'm going to jump to the interesting stuff. So, let's go back to our Twitter app. Now remember, you can do a lot of fun stuff with Meterpreter. We got a session, and we want to now run our little script over here that is going to hook exact methods for a particular process. And we're going to get the session that we have. So now we've got a Meterpreter session. And in Meterpreter and Android, you can run shell commands straight through. And you can see we ran an ls over here, but nothing came up in our script. No hooks came, so that means it's doing something different. But what you can do in Meterpreter is you can drop down to an interactive shell. We just ran that command and we see something came up in our terminal, which says a call came to, and the parameter that was sent to exec was sh-c sh. Those of you who are familiar with reverse shells in the Java space, or on Linux, that is, if I saw my Twitter app doing that, I'd get a bit of a fright. But of course, we've infected this one. And you can go ahead and we actually play with the shell and we see what happens, and we run some commands and nothing else actually comes up because it's using sh-c sh, it's using that pipe. So it's actually not running runtime.exec every time on every command. It's running it once to get a shell session and then running it within that pipe. So that's one way that you can use to instrument and see how applications are using runtime.exec. So this is all fun, this is all from our desktop, and at this point we have the ability to analyze objects on the heap. So that's the important area that we are looking at. We can hook functions, we can do all of this at runtime on a device, and we can see more than static analysis. Hopefully I've convinced you of that. But we're doing all of this from a workstation. Now, earlier I was ranting a bit about, well, I don't want to do this from a workstation. I want to do this from an Android device. I don't know why I'm pressing the button. I've got a clicky pointer thing. And before I get into that, I'm going to just introduce the attestation API. Very cool. Anybody heard of it? Yeah. If you're into mobile and Android stuff, I highly recommend you look at this. It's very interesting. But basically, in the Android ecosystem, it allows you a way to gather information about the device. Bad example is the device rooted? Is it using a signed ROM from Android? Is it using something else? So basically, apps can use this API to query the environment in which they're running in. So apps mostly use it to say, hey, has the cert store for this device been compromised? Is it rooted? So on and so forth. So it's an API with a lot of things that go on. So I thought, well, there's an API that exists already in the Android operating system to query the device. And that kind of lives over here. If you look at the architecture, sorry, once again, I apologize for showing you architecture diagrams on a Saturday. But at this point over here, it runs on the device, and as the client, you query that. So I thought, well, what if we could do something here? What if we provide an API that could allow, I'm not going to say third-party apps, but that could allow something to query the system and say, hey, process X that is using a lot of battery, don't you just want to give me some information about it? Yes, I know alarm bells are going off, and I'll mention that later, but that was the idea I got. And what I landed up hacking together was something called 8cake. So if So this is reason Afrikaans in South Africa, or if you speak Dutch, you'll understand why it's called 8cake. So yeah, Google Translate might be your friend, or I'll tell you later. But you can use this API to basically query the functionality that I'll show you now. You can do this from an Android application. So basically, it's a custom Android Frida library, so you can interact with Frida via an Android application, so not from a desktop. It's essentially dbus over TCP. Yes, I hated life very much after looking into the world of dbus. And this basically allows you full Frida server integration. So if you're not familiar with Frida, basically it's an agent that you query, you drop it on a device, or you can use a gadget and embed it into an application. I won't go into that. But what's cool about this is that you can run all the tests that I demoed earlier. You can run this via 8cake. You can say, give me the processes for a system, or you can say, process X, tell me if it's using objects A, B, and C, and give me the values of these objects at runtime from an Android app. So, for example, if you were to say from the Frida CLI on your host, you would say, hey Frida, give me all the running processes on the device, you would say Frida-PS -U for USB, and you'd get this stuff. Pretty useful. If you wanted to do it via 8cake, you would, and I said the word instantiated probably way too many times in this talk, but you would instantiate an object of 8cake, and you would just say 8cake utils, whatever you decide to call it, .frida-ps, you give it the name of the daemon and the port that you want to connect to, and it'll go ahead and return those results to you. If we look at the early examples, I didn't do anything, that wasn't me. Haha, cool. I think that's a sign. Even the presentation is getting annoyed with my voice by now. So that's a sign for me to hurry up. But yeah, those are the scripts earlier. Remember when we were analyzing processes and saying, hey, if these objects exist, give me the information from my workstation. This is how you could do it in 8cake. So just 2 lines of code there. So why 8cake? 8cake? Well, there was no Android Frida library. There was no way to interact with it on Android through an Android application. I wanted to use Frida for its object carving capability. That I think is its strongest use. I wanted a client-server model to interact and integrate with the existing attestation API. You query something, get a response. And I didn't want pain. And that comes from this text, which is highlighted, which says, so I realized that Frida was using dbus, and I thought, well, I want to speak dbus in Android, and there is no, on the operating system level, there is libraries, but not in the Android layer. And when I looked at the dbus documentation homepage, it literally says, if you use this low-level API directly, you're signing up for some pain. I shit you not. It is, you go to dbus.freedesktop.org docs. It says that. You have, exactly. So, my reaction then was, just GTFO. But of course I didn't. I continued. And basically, what I did was sniffed a whole bunch of Frida sessions between a device and a host, and basically implement a TCP socket daemon to initiate that, implemented dbus over TCP. It's ugly. My code's ugly, not dbus. Got it from sniffing Frida sessions, and basically try to identify what dbus flags I could send from the Android library to the daemon. And basically, if you look at the source code, you'll just see a whole bunch of bytes, because a lot of them I don't know what they do, but it works. And I just highlighted, I looked for the bytes that I needed to change in the protocol, for example, to specify PIDs. So I don't want to look at PID 1, 2, 3, 4 every time. No, PIDs change. So I had to manually hunt down the bytes in the protocol and a whole bunch of other stuff. And that's really what it looks like. And a lot of trial and error and a lot of swearing, and yeah, but it kind of works. This was the original POC. So right in the beginning when I had the thought, I was like, cool, let's get this to work. And if you're familiar with dbus, you'll see basically a .auth. And what's interesting about dbus is that there is really no auth. If you send an auth packet, you'll always get a auth-anonymous rejected reply. So if you're scanning any sockets and you get that kind of reply, it's dbus. So that was some really nasty Python code. And why I like to show it is that it actually worked the first time, this kind of thing. It's basically a replay attack. And I was not expecting that. So, yeah. And then decided, well, let's turn it into a Android library. which is this demo over here. So once again, we've got our Twitter infection. So this Twitter app is infected. As you can see, that is why I am not an Android developer. I stick to the default Android Blue. It's very soft on the eyes. So the first command I ran there was system processes, and that is basically -ps -u, but from the Android app. And we can see we've got our interpreter session. I'm now providing it the PID of the Twitter application, and I said hunt malware. We give it some time. Don't go for a coffee break. There's not enough time. But we'll get some information back. And you'll see I'm just displaying the raw output here that you get back, but what we saw from those Frida scripts, all the information about the DEX class loaders and the TCP sockets, we're now getting that at runtime via the application. So now if, I don't know, if this was an app that said, hey, let's look for dodgy looking apps, you could use that and say, hey, if this app is using object X and it has these values, you can implement some logic. So that's how 8cake works. Yeah, it's a lot of fun. I enjoy it. Besides what I've been going on about, it's about pain. That's just dbus. But the code and scripts are there. The videos that I did show you are available. You can trust that, minified link. It's fine. But if you Google, you'll find it. So all the stuff's living over there. And of course, yeah, there are obviously shortcomings with this kind of stuff. This is an increased attack surface. I mean, if I was trying to pwn Android and I find out that there is a process that analyzes the memory of other objects, oh my word, that sounds delicious. So yeah, I'm still actively researching how to maybe isolate that. I think it would be a great API for internal Android services, and only read access for particular objects. So kind of like the dangerous and normal permissions model, that maybe the system process could only be allowed to look for maybe dangerous objects, so like objects specific to overlay attacks or certain view gadgets, and maybe anonymize it. I don't know. So yeah, it opens it up for abuse. This kind of stuff could be abused. And of course, the pessimist in me is just like, well, we still struggle to get basic security right. So how is something like this that's going to be actively looking at the memory of other processes going to work out? I mean, that kind of exists in desktop environments. I'm not going to mention any names. But to see how that's worked out. So, of course, there's shortcomings to it, but it's research, it's fun. Of course, there is a conclusion. So a lot of the stuff, it's a journey. I think it's a step in the right direction. I think some very clever person once said, and I'm not going to quote directly, but they said something about if you're doing the same thing over and over and expecting different results, something might not be right. So I'm like, well, let's try something different. For shits and gigs, why not? There is no silver bullet in security. This is definitely not going to solve all your problems. I have some alternative solutions, but this might help with maybe defense in depth, maybe. But at the end of the day, I think the Android operating system is key to protecting itself. Third-party applications don't have the capabilities, they're not provided with the capabilities to actually do anything meaningful besides run a grep over an APK. So, I mean, yeah, that's the kind of stuff that we're looking at. And yeah, so how are we doing on time? Cool. I'm going to open up the floor to any questions. Yes, there's a question. There's a microphone.
Nice. You were talking about tracking the things like run the process that execute the one that executes commands on the EOS.
Yeah.
That's a static class, if I'm not mistaken, right?
Yes.
Yeah. Have you tried to dig into the permgen memory area of the Dalvik? Because the permgen space, in at least from my memory of hard times of Java development, that's where class metadata and static variables and all that stuff is stored. So you probably will hit something there about the reserved areas of the last values used on some of those stuff. So probably give it a try.
Nice, yeah, that's a great idea. Yeah, unfortunately, I've opened up the Pandora's box of Android memory. I'm just like, what am I doing? That's a great idea. I'm definitely actually going to look into that because, yeah, that seems like something that should be predictable. So yeah, thanks. I appreciate that.
Any more questions?
At the beginning of the talk, you said that there was no efficient way of scanning for malware on Android, and even this solution, I think it's not for the common user of Android, because from what I know, on Frida, you need to have root, or you need to disassemble the package to inject Frida, so it's not a solution for the common user. Do you think there could be a solution for the most of the people, or it's something that's out of scope?
Yeah, I think it takes away the need of, for example, users having to set up Frida and do their own thing. So I think if it's somehow bundled as a system service that the user doesn't see, but the system service has this kind of capability, then it could add value. It could say, well, okay, at runtime, this app is using these kinds of objects. It is said that it doesn't need to, but it is. Send off some alarm bells. So I would definitely not recommend this stuff being exposed directly to a user, unless we really hate them and make them want to suffer. But I think if it's abstracted and bundled in as a system service, where the system does the heavy lifting and just says to the user, hey, there's something wrong here, maybe submit it, or throw your phone in the nearest bin. So I don't think it solves that problem entirely, but I think it's kind of a step in the right direction. Does that answer your question? Cool.
I actually have a question. By the way, thank you for the excellent presentation.
Thank you for having me.
This has to run. This is there has to be a thread in a process so that attaches to the application and dumps the objects. What happens if the attacker or the Trojanized application has a timer that instantiates an object, does the evil things, and then destroys the object? Is there any trace that could be looked for?
So is the question, so would there be a way to detect if an evil process is instantiating an object, doing what it needs to, then getting rid of it? Great question. I would probably look for any garbage collector calls, anything to GC that would force it, or any, I don't know any other ways that would be able to force that off the heap. But
you can't call, you can't force it. You may try to call to force the heap, to force the garbage collector to clean itself by the system something else, but it's actually a queue. When you call that method, it places something inside an internal queue, and the next time it runs, it goes over that, it will take that thing and call the GC. So even if you try to instantiate something, do some evil sketchy thing, it's not guaranteed that will be out of the memory before you can try. So if you're monitoring the thing, you'll probably hit it.
Yeah.
Any more questions?
Cool. Thanks everyone for your time.
Thank you, Chris.